Hi guys, here's my idea of using a relay, an automotive relay, to do a in-flight switching power source. So you can actually switch between a lithium-ion battery, which is good because it's super light and it's got a low capacity for its weight, the ratio, compared to a lithium battery, which is heavy for what it gives. So, but the lithium-ion is good for low C discharge. 1C discharge is best for them. So let's see. Here I have the two sources of battery. This is the input. So this is a 4-cell. This is a 3-cell for this example. I've got a 3-cell here, and there's a 4-cell. Then you've got the relay, goes into the relay, and then from here you can switch between either one of this or that one there. Then it goes to output, wattmeter, just for our information, to a ESC, to a motor. On the ESC, of course, you've got your throttle input, which is simulated by a servo tester. And then on the relay side of things, there is a coil which needs to be energized to pull the contact from one to the other. Okay, when it's not energized, meaning no power to the relay, you'll be at a default position, which will generally put it onto the lithium ion pack, because that's your main pack for flying, your big pack, and this is just your high discharge. You can use this lithium polymer for your taking off at full throttle or climbing to altitudes at higher amperage than you would for cruising. And this switch is just a little simple switch, which basically that's a 2-cell. It should be a 12 volt going to your relay, because this relay is a 12 volt relay. So, but for this example, it still works with a 2S. So what this switch actually does, it just basically cuts the power to the relay. That's it. It basically cuts it, or it lets it flow. So when it flows, you can see what it does. And essentially, this switch will be replaced by a RC controlled switch, which will be which you can buy online very easily to power your LEDs. You can turn your LEDs on and off, and some of them they can handle quite a few amps, like 2, 3, 4, 5 amps. But for this application, milliamps is all that we need. And of course, this switch then, the RC switch will be plugged into your receiver, whether it's a long range system or a 2.4 gig receiver, and from there on a spare channel assigned to a switch on your actual TX, your transmitter, you can flick it, and then you can cut the power to the coil, or give the power to the coil, which will then flick it from this to that, by a flick of a switch. So at the moment, I've got the 3S connected, which is that one there. You're looking at 3S, and let's flick the switch here. Boom, and it's gone to 16.2 volts, which is a 4S. So by this little switch here, which is generally controlled in real life, would be from your TX transmitter. 3S, 4S, 3S, 4S. Let's leave it on 4S. In this example, this is going to be the LiPo. This is going to be the ion, lithium LiPo. Sorry, lithium polymer. So let's go LiPo, and for taking off. Boom, throttle is on. There we go. It's spinning its head off. It's drawing from this pack. 16 volts. Let's switch over. You can hear the RPM drop because it's running off a 3-cell now. There you go. 3-cell. Switch over back. 16. And I can do this all day. 3-cell, 4-cell, 3-cell, 4-cell, 3-cell, 4-cell. The right procedure, if I can sort of probably advisable, is to, when you do it, when you ever switch it, is to take the load down to 0, throttle down to nothing, change it from a 4S to a 3S, and then go and cruise. There you go. Apply throttle, flying around. Oh, let's say I want to climb to altitude with a bit more power than usual. If you want to do some fast climbing, throttle 0, switch it down to a 4S, boom, with a LiPo, high discharge, and then you climb for your life. And then cruising again, boom, flick it over, and then cruise. But in this example, as you can see, I can switch it, and it's no problem at all. In theory, the voltage totally cuts off for like some microseconds, like 5 milliseconds or something, when the relay actually switches from one contact to another contact. But that doesn't seem to affect or upset the ESC to reset. I thought I bought some capacitors just to see whether maybe some caps would hold the voltage, but it seems that microseconds, should be 5 or around there, I think, does not affect this at all. Yeah, so that's cool. But one other thing I noticed, since I'm running 2 different voltage, in FPV you stick to 1 voltage. If I turn on the power to my ESC with a 4S, correct, and then do my testing, I find that when I switch to the 3S under power, the low voltage will kick in and cut the throttle. You actually and ramp down the RPM on the throttle. That's because you started off with a 4S pack, and then the ESC has registered 4S, and then from there on, it is detected, oh, your voltage has sagged, so it's going to kick in the low LVC. But in real life, you should disable your low voltage setting anyway, or you just set it very, very low. Some people said put it onto the NiCad or nickel metal hydride settings and put it on low, or disable it if you can. If it doesn't, put it on the lowest. But in actual fact, you won't run a 3S and a 4S on a FPV platform anyway. You run both at the same voltage. So a 16.8, a 4-cell lithium ion, a 4-cell lithium polymer, and then with the correct setting on the low voltage, it shouldn't the LVC should not even be a problem at all. So that's what I've noticed. But for this example, I booted the ESC up with a 3S, which allows me to run a 4S and a 3S. Voltage doesn't sag below the LVC because I haven't set this low voltage yet. So that is the end of my test. Any feedback, any question, any concerns, I hope we can discuss it. And if this could be used in a practical way to run a lithium ion battery, which is good for cruising, but not good for high current. 1C discharge is what they really like. 2C seems to be fine. Excuse me. But definitely a 4S with 35C or whatever, they can give you plenty of discharge. And if you have independent separate packs, that means the batteries are not charging each other, which can be dangerous. Voltage difference, battery charging each other between them on parallel, which can be a concern. So yeah, so here we've got 2 different independent, and all your current sensor and voltage sensor will be wired up on the output of the relay. So when you make the switch, the voltage will register straight away on the pack that you're actually running. Excuse me, darling, Daddy's filming. Okay, and then the milliamps that's consumed will keep counting anyway. Your current sensor doesn't turn off when you make the switch. It just for the 5 microseconds makes the switch and continues, and the voltage will be the live voltage of any pack you choose anyway. And let's say this is a lithium ion pack. You wire all your autopilot, or your UBEC, or your 12-volt system for your video transmitter, your camera. The whole lot will be all on this pack, the main pack, all right? So it doesn't even the switching doesn't even affect it. Your system will be online all the time. And like I said, if your relay does fail, make this, the ion pack, the default position. Solder it up or connect it up so that if your coil fails, your switch will flick back to the default. Non-energized coil will be on your lithium ion, and only when there's power applied, you'll turn on to the lithium polymer when you apply power. So that's fine. Oh, there is little Naomi in the background. They don't play with dolls and teddy bears. They play with ESCs, lithium batteries, and whatnot, motors, gears, props. So give me your feedback to see what you reckon of this setup. I think this could be quite practical. In fact, yeah. Thank you.